So today what we're going to do is we're going to talk about what's something called the normal distribution. So we looked at last time in that video, I talked about ways that that you can do basic probabilities, and then we looked at some distributions, those graphs. And the last part of the distributions or graphs, we looked at some shapes and some different things. So they can be bimodal or have one mode. They can be triangular, or they can have what's called a normal distribution, which is a curve. And so we're going to take a look at that, and then we're going to look at ways to be able to find or to use the normal distribution. So here's the Walker book talking about the normal distribution. It's used when you have continuous data. In other words, it can't be like data that has to be in pieces, or that can't be in pieces, things that have to be like halves and etc. And the data is clustered around a central value, and it's always symmetrical. So here's an example of the shape of the normal curve. Notice that it goes down at both ends, and right in the center is where the high point is. Okay? And we're going to talk a little bit about this distribution, because you do need to understand some things about it in order to be able to do the problems. Although, oddly enough, the calculator is going to be able to do most of the work for you. So most people are pretty happy with this section. So let's talk about some of the pieces of the normal curve, the normal distribution. So here we have one that is a very standard normal distribution, and we have a couple of pieces that you need to be aware of. The line that cuts things down the center of the distribution is the mean of the data. And the mean of the data has two different ways you can write it. This little funny M shape is called mu. That's one of the symbols for mean. Or you might see it as an X with a bar over the top of it, really creatively called X bar. But usually you'll see this because it stands for the population mean, so the standard, so the mean that we're going to be using as we go. You're also going to see that each of the sections of the curve are divided into equal parts. And those equal parts are called standard deviations. Standard because they're all exactly the same width, and deviation simply means how far something is separated. Okay? So they're all equally distributed, equally spread out from the mean. And notice that there's 1, 2, 3 of them on the right, 1, 2, 3 of them on the left, and to indicate that they're on the left, they use the minus, right? So -1, -2, -3. So -3 really means 3 standard deviations below the mean. Okay? It's important that you understand how this distribution is set up so that we can find the appropriate area, so that we can then use that area as the probability. And some of these, the probability are really well known. If you go from one standard deviation above the mean, for example, that's like 34.1% of the data. Something that you do need to remember, is that the mean splits the data in half. So if you think about it, if you have the whole thing, that's 100% of the data, right? But the mean splits it in half, so this side is where 50% of the data is, and the other 50% is below the mean. That's something that you need to memorize and make sure that you really understand. The whole graph equals 100%, and each half, split in half by the mean, is 50% on either side. Okay? That might not seem very important to you right now, but later when you are answering questions, it's going to be. Again, we're going to be using the calculator for most of this, but it's still important that you understand how the data is distributed. Okay? All right. Now, Normal distributions can have lots of different shapes, but generally it's something like this. Don't concern yourself too much with that. It's no big deal. And the probability for an event can be found by simply using the area under that normal distribution. Okay? Don't worry about the z-score right now. We'll come back to it, and you will be given that formula on your formulas page when you do take this assessment, so you don't have to memorize it, but we will come back to it and use it. So here we go, and here's a distribution of heights with a mean of 150 centimeters and a standard deviation of 5 centimeters. So 150 centimeters means 150 is right in the middle, and each line, and remember there's 3 above and 3 below, is a standard deviation of 5 centimeters. So you'll see if it's 150 in the middle, then it's 155, 160, 165. So in other words, they're adding 5 to each one. And as you go down, you're below the mean, so you're getting smaller by increments of 5. Again, don't worry about these z-scores. That makes no difference to you right now. Do, however, notice that this is the x-axis, a number line, and it's labeled with the thing you're measuring and any units that you're using. So if here we have x, the x-axis, which stands for the height in centimeters. Okay? So because we have a standard deviation of 5, we're going up by 5 as we go to the right, down by 5 as we go to the left. You will have to draw a curve and put the appropriate numbers in. Okay? But it's just simple math. Okay. And again, we can use this in order to be able to answer some questions. And they're calculating z-scores. We're not doing that. You do not have to calculate z-scores. Again, you'll see why. And then you could go on to use those z-scores to calculate probability, remembering that probability of 0 means that the event is impossible. Probability of 1 means it's a certain event. And right down the middle, you have the 50-50 chance, half. But again, we're going to use our calculators to be able to do these. So what you need to know is you need to be able to read the values. And again, they're going to give you areas. These areas, like for example, this particular area of 0.34, that is the probability of an event. And of course, you can give it as a decimal, or you could change it into a percent, right? Okay, so it can be written into several different ways, just like when we looked at probability before. So what we're going to do is we are not going to be using these probability distribution tables. You do not have to learn them. You do not have to know how to use them. You will not have to use this particular formula right now to find a z-score. We will use it for something else later. Instead, we're going to be able to use our calculator, and that will be true of the test as well. So don't worry about the z-scores. You also don't have to worry about where things are, because you're going to see that the calculator will do that for you. You do, however, have to be able to draw the curve, right? They'll give you the mean, they'll give you the standard deviation, and you have to put the right numbers in the right spot. And then you will have to determine the shading. So we'll talk about that as well as we go. Okay? How's it look so far? Don't know because you don't know what I'm talking about? All right. Just y'all are still there, right? Okay. Just checking.
Still here.
Still there. Good. I always feel like I'm losing you here. Okay, so no big deal. All right, now, so what I want to do is I want to go to the calculator instructions. Don't worry about any of that. How lucky are you? Keep going. Don't worry about that. We'll talk about these in a minute, but what we're going to do is we're going to there we go. So what we're going to do is we are going to use the graphics calculator to calculate probabilities. So this is where I need you all to be on point, okay? Now, So what I'm going to do is, here are the directions. It's on page 33 in your book, but I'm going to actually walk you through it. So right now, I need your calculator and your hot little hands ready to go so that you can push these buttons with me so that we can make sure that you know how these problems work. Okay? Everybody got your calculator? If you don't have a calculator, then you can follow along with me, but take notes. But I'm going to also put notes on here. Okay? So let me show you first of all how to get to the screens that we need and then the keystrokes that you're going to have to use in order for this to work. Oops, I can't write on the screen and use the calculator at the same time. First thing is that the default setting for your calculator is always the math setting. Okay? You don't want that. So what you're going to do first is you're going to go to the menu. Whoa, that's terrible. Let's try bright yellow on this gray and see if that's better. You're going to go to the menu button. Okay? Menu, right there. So everybody please push that button. Okay? And when you do, this main menu appears. And we're going to be using the statistics menu. So to choose the statistics menu, you're just going to hit the number 2 on your keypad, because the statistics menu is the second menu. Okay? Now again, I can't do that with this writing on there, so hopefully you're taking notes and writing this down so that you know what things to do. But it's again in your book on that page. Sorry, I forgot what I was talking about. So, menu, this one's already at menu. Hit the number 2, and boom, it just comes right up. You don't have to do anything else. Okay? Now, we are going to be working with distributions here. Okay? There are lots of other things that we don't worried about. All we're worried about is distributions. Okay? So that's the next keystroke that you're going to make. So here we go. And you know that to hit one of these, that's the keys down here. So the F5 key. Okay? And we're talking about something called a normal distribution. So you're going to hit norm, which is the F1 key. Okay? Now, notice that we have 3 options here. Now, we need to choose the correct option. And the correct option for what we're going to be doing in this section is that NCD button. In other words, F2. Hopefully you're all pushing these buttons down, okay? Now, then you should get a page that looks like this. So it says normal, CD, data, blah, 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 blah. Now, the default is the list view. We don't want list view. What we want is the variable view. So your next step is variable, or F2. Okay? And when you click on that, F2, then you're going to see it changes the data from list to variable. If it's not on variable, then this won't work. Okay? Now we have some buttons here that some information that we're going to fill in, so we're going to talk about each one of those. The first thing you see is the lower, and what we're talking about there is the lower limit for your data. Then you have an upper limit for your data. The questions that you get are going to give you some parameters, some numbers that you're going to be looking at. These are the z-scores, not the z-scores, but the limits, the data of the number of standard deviations above and below the mean. We can tell one is the lower limit because it's below the mean, or it's the smaller number. The upper limit, it's above the mean, or it's the larger number. And you're going to look at lots of examples, so it's really easy to just do that. That funny little O with the tail on it is the standard deviation. And they have to give you that number. It can be a decimal, it can be a whole number, but it'll be the standard deviation. Then we talked a little bit about the funny little M thing, the mu. That is the mean. And again, they have to give you that. Okay? Now, sometimes for the upper limits and lower limits, they won't give you a lower limit because it goes all the way down as far as you can go. Some other times they won't give you an upper limit because it can go all the way to the right as far as up as there is. So they only give you a lower limit but not an upper one, or they give you an upper one and not a lower one. So we need to talk about what to do in that case. Okay? So let me just get some room here. Because we want to make sure that we're getting all of the data. If there's no lower limit, just put in -9999. 5 nines should do it. If no upper limit, just put in 5 nines positive though. Because again, you have to know, it's lower, it's going to be a negative. If it's upper, it's going to be a positive. Okay? You can use 1 with a bunch of zeros after it if you want to. It's traditional to use 9s, but it really doesn't matter. Okay? But what you want to do is you want to use a number that's really, really big so that you can make sure you're getting all of the possible data. Okay? And once you've put all of that information into your calculator, then you just hit execute and it'll give you your answer. All right? So yes, you have to learn the keystrokes that you need, but once you put them in there, your calculator will stay in. As long as you go to stats mode, it should revert right back to what you put in, the variable, etc. So you shouldn't have to do this over and over again. But you should do it over and over again, because remember, when you go to take your test, I'm gonna make sure that your calculators are reset, right? So, all right. So you ready to push some buttons? That's difficult work we're going to be doing here. So let's look at a problem here. So this is one of the questions that you would have worked in with using the charts, but of course we're not using the charts, so who cares? Oops, sorry about that. So the weights of students' backpacks are found to be normally distributed. Now, if you don't see that phrase, normally distributed, then you're not talking about the normal curve or the normal distribution. They always have to say that. With a mean of 3.3 kilograms, so your mean is 3.3. You're not worried about the units right now, but when you because you're dealing with probability, you don't ever care about the units for that. And a standard deviation of 0.3 kilograms. So a standard deviation of 0.3. Okay. Calculate the probability of the backpack weighs between, and that is a huge key word right there, between. That means they're going to give us a lower limit and they're going to give us an upper limit. And so it's between 2.7 kilograms and 3.1 kilograms. Those 4 pieces of information are enough to be able to do this entire problem and get your answer. Okay, so I'm just going to walk you through because they've got the pictures here of them doing this very problem. So you'll notice that they've done NCD, not NPD or not inverse, but the middle one, right? And then also make sure that this setting says variable, not list. Okay, so be careful about that. you'll see that all they've done is put the proper numbers in the proper place. The lower limit was 2.7, upper limit was 3.1, the standard deviation was 0.3, and the mean was 3.3. Right? So all you're going to do is just put in the numbers that they give you. Don't have to do anything else. Then you hit execute, and boom, there's your probability. Okay? Don't worry about these z-scores. We don't care about these right now. They're going to give them to you, but we don't need them. This number right there is your probability and your answer. Now, again, they're telling you that you might get different numbers if you use the table. So if you try to compare it to the table number, it might not work. Okay? And I do not want you to round unless they ask you to round. But if you do round, it's usually 4 decimal places. So if you do round, it would be 0.2297. Probability is usually given as 4 decimal places, but unless they tell you to round, don't do it. You can write down those numbers. It's not going to kill you. Okay? We'll check the answers in the back of the book. If they consistently round to 4 places, then I'll let you. But if they don't, then just don't do it. Okay? Right. Sounds horrible? You should be pretty happy right now as long as you have your calculator in front of you. All right, so let's look at some more. Okay, here we go. The weights of students' backpacks are found to be normally distributed with a mean of 3.3 kilograms and a standard deviation of 0.3 kilograms. Calculate a probability the backpack weighs more than 3.7 kilograms. Okay, so here we go. We need our pieces. First of all, we need a lower limit. Well, think about what's happening here. We have our distribution. We have our mean in the middle. Okay, our mean is 3.3. We're measuring at 3.7, so 3.7 is over here, and the data we're looking for is on this side to the right and goes on to the right forever. And we know that because it says more than 3.7 kilograms. So 3.7 is our lower limit. Notice they just use 10,000. That's where I use 9999, whatever. It's fine if you want to use the one with zeros, or you could use the nines. Makes no difference. They put in the standard deviation. They put in the mean. Push execute. And there's your probability. Is that number there? Again, don't worry about the z-scores. We're not worried about those at all right now. Are you sad?
A little bit.
Oh, because I'm not making you do it by hand. Poor thing. Okay. At university, I would have made you do all of this by hand, including finding the standard deviation. I was pretty evil. Okay, so let's look at one of these. Just the estimated lifespan for a kakapo, I don't know. A rare New Zealand ground-living parrot is 95 years. Wow. If the lifespans are normally distributed with a standard deviation of 11 years, calculate the percentage of kakapo that live more than 120 years old. So in this case, there are a couple of things we need to talk about. First of all, average lifespan is 95 years. That's the mean, right? So if we draw this out, then the mean is 95 years. The 1, 2, 3 on either side. I want to see the picture. Draw the picture. Okay? And then the standard deviation is 11 years, so you just add 11 all the way across to get the ones above. You subtract 11 to get the ones below. You're the ones with the calculators in front of you, so that's easy to do. Okay? They want to find out how the percentage of kakapo that live to more than 120 years old. Well, more than 120 is, so say if 120 was right there, more than that is to the right. Yeah? So is that an upper limit or a lower limit, the 120?
Lower.
It's a lower limit, exactly. Good. So we have our mean of 95, our standard deviation of 11. We have a lower limit. I'll just write out lower since that's what they write. Lower limit of 120. And we don't have an upper limit, so you can use whatever you want to. 10,000, 9959s, it doesn't matter. Just use some big number that guarantees you're going to get all the stuff you need. Okay? So let's just go to the calculator to simulation to do that. Again, it's already there, variable, so we're just going to put in our pieces. Our lower limit was 120. Our upper limit was all there is. Oops, sorry, forgot to go. You have to push execute between them, I'm sorry, to go from one to the other. So 5 nines ought to do it. Enter that. The standard deviation was 11. Enter. Our mean was 95. Execute. And execute again to get the answer. And there's our probability. 0.01152131. Math with no math in it. Couldn't be easier. Okay. So look at this one. Calculate the probability that it lives between 90 and 100 years. So if it's between 90 and 100 years, then 90 is your lower limit and 100 is your upper limit. The standard deviation and the rest of it stay the same. Okay? Longer than 80 years, so that means a lower limit of 80 years. So you'll put an upper limit of whatever. Something big. The calculator part of it never changes. Your job is simply to decide which one's the lower limit, which one's the upper limit, and put it into the right spot. Okay? In March 2014, there were 130 living cockapoo. How many would you expect to die before they are 70 years old? Okay? That's an expected number. So if they're going to die before they're 70 years old, that's an upper limit. So first of all, you have to have the percentage. That's an upper limit, of 70. So for your lower limit, okay, you want everything, but every cockapoo that's lower than that. Once you get that probability, you'll take the probability times the number of birds, and that will tell you how many. So just find the probability, multiply it by 130, and that'll tell you how many. Oh, and by the way, up at that one earlier one, they wanted it as a percent. So if you gave me this, I'd be unhappy with you. Instead, it's about 1%. And if you round it and don't say about, I will be unhappy with you there too. Okay? That does not look like about at all. Let me try spelling that again. So be careful. Normally a decimal is fine, but if they want a percentage, then you need to give the answer as a percentage. And that little trick on the test is the difference between achieve and merit. Okay? So they get really picky about it. Okay? Let's see. Okay, energy saver light bulb lasts longer than 11,000 hours. So 11,000 hours is the minimum we want, so that's the lower limit. Between those two values. Doesn't matter that the numbers get big. Between, there you go. there are 950 bulbs. They want to see how long if they last more than 8,000 hours. So find the probability for 8,000 out for above 8,000 hours, and then multiply it times 950. That's called expected number. And again, that's just the probability times the number of items. Look good?
Yeah.
Such a deal. Okay, well, let me get rid of this then. Stop the recording.